Hello, everyone. Welcome back. Today, we're going to learn how to solve what are called rational equations, or basic equations involving fractions, more specifically when you have a variable in the denominator. So our goal is then to be able to solve these kind of equations and also recognize when a result is not actually a solution of a rational equation. We'll explain how that can happen. So a rational equation, or what's called a fractional equation, is an equation that says in which the variable is in the denominator. Okay, so it's not simply an equation with any fractions, but specifically a variable is a denominator. So a good example is one like this. Okay, we're solving for x, where x has been in this case in both denominators. In fact, we'll do this one here in a moment. This is what's called a rational equation. It's going to fractional equation. Now, to solve these, what we have to do is we're going to factor our denominators if necessary, and determine what we call the restricted values. Restricted values, anything will make the denominator zero. And we'll see some examples of that. Okay. Then, just as we do with any time you have fractions in an equation, find the least common denominator, then multiply both sides by that least common denominator. In this case, that will involve some expression of x or whatever our variable is. And then the equation we get out of that should have any denominators. We'll solve that. And then we have to make sure that the solution we get is not actually one of these restricted values. It's not something that makes the denominator zero. If it does, then then that number is not a solution to the equation. It's even possible for equations like this to have no solutions at all. Let's come over here to the right and take a look at our first example. So I'll simply say solve. Now first, let's do just an example with regular denominators to kind of review how this works. I want you to see that the process is very much like what we do when we have an equation with just any kind of denominator. So let's say we have this equation, x over 3 plus 1/2 equals x over 4. Okay, now, in this case, make sure denominators are all, if you need to factor anything, make sure that they're factored. Okay, the simplest terms they are. All right, so take a look. Now here, in this case, there are no restricted values. I'll just go ahead and say that. Because we don't have any x or any variables in the denominator, so there's nothing can make any of our denominators zero. So no, we're called no restricted values. Okay, none of those. Now, our least common denominator, LCD, is going to be the smallest thing each one goes into. If you notice, between 3, 2, and 4, actually LCD is 12. Okay. And actually that's, and also 4, remember, is 2 squared. So actually, yeah, so 4, let's point that out, versus 2 squared. So it turns out the least common denominator is actually 12, which is actually 2 squared times 3. All right, now multiply both sides by 12. Oops, hang on. Ahead of myself. So plus 1/2, then parentheses, then 12 times x to the 4th. Okay, so this side, I'll go into the right side first, multiply across. This is going to be 12x over 4, which that will reduce. And here, distribute the 12 to both numbers. So 12 times x over 3 plus, since we have a plus, and 12 times 1/2. The same thing here. Let's multiply both these across, and both these will simplify. So it'll be 12 times x, or 12x, over 3 plus 12 over 2. Now this simplifies. 12 over 4 is 3, so this is just 3x. Okay, and so this then is going to be 12 over 3 is 4, so 4x plus 12 over 6 over 2 is 6 plus 3x. Okay, now I'm just going to get the x's on this side, so subtract 4x on both sides. And so that's going to give me 6 is equal to negative x. Then, of course, just divide both sides by -1. Then I'll turn this around. X is equal to -6. Okay. Now, we said we had no restricted values, so nothing, there's no way plugging x into 6 will cause any problems. You can't make the denominator 0 because there's no x in the denominator. So this is our solution. Okay. All right. Now, let's take a look at our first example. In fact, let's do this one right here. And we'll see how this works. So I think I'll just start down here. So number 2. So 2 over x minus 1 is equal to 3 over x plus 2. Now, this time we do have restricted values. Once again, we know restricted values. Take a look at our denominators. They're already in factored form. Don't have to worry about factoring them. This one, if x is 1, that would make this denominator 0. So what that tells us that x can't be 1. And here, if x was negative 2, it would make this denominator 0. So x can't be negative 2. So I'm going to put a box around this. We're going to come back to these later at the end. Make sure the solution we get is not with these numbers. If it is, then there's no solution. That number is not a solution. Okay. Now, this process works just like above. So our least common denominator. So make sure our denominators are factored. If they are, then basically our least common denominator in this case is just simply going to be these two multiplied together. So it's going to be x minus 1 times x plus 2. Okay. And as we did above, we'll multiply both sides by that. And so we have x minus 1 times x plus 2 times the first times the left side, 2 over x minus 1. And then our LCD times the second side. So x minus 1 times x plus 2 times 3 over x plus 2. So the bad thing about these problems is that there's kind of a lot of writing involved, unfortunately. Okay. Now, the good thing is, though, this simplifies, is once again, after this step, like we had in the previous equation, there shouldn't be any denominators left. So you notice x minus 1 will cancel out. What we're left with is 2 times x plus 2. And over here, the x plus 2's cancel out, and we're left with 3 times x minus 1. Okay, so distribute. So you have 2x plus 4 is equal to 3x minus 3. And then just solve this. So it doesn't matter. I'll get my x's on the left side. So if I subtract 3x on both sides, over here, then I have negative x plus 4 is equal to negative 3. Then subtract 4 from both sides. And so that's going to give me negative x is equal to negative 7. And then finally divide both sides by negative 1, or multiply by negative 1. And so x in is just positive 7. Okay. Now, what you need to do now is go back and check. So we said our restricted values, make sure it's not one of those. Our restricted values, things that make our denominator 0, are 1, negative 2. So this is x equals 7. Of course, this is not a restricted value. Let me just abbreviate that. Okay. So this is our solution. Since it's not a restricted value, that's our solution. Okay. So that's the basic process of these equations. Essentially how they work. All right. Let's take a look at a third one. Like I said, the bad things about these, they tend to be kind of long to write out. The essential process we're going to do is basically what we just did. So let's take a look at the next one, number 3. Okay. So we have 3 over m plus 2 plus 2 over m is equal to 4m minus 4 over m squared minus 1. Now, what I want to do is factor our denominators. Just write that out. Okay. Now, these two are already factored. You can't factor m plus 2 or m, but this one actually can factor. If you remember difference of squares, this factors into, I'm sorry, this should be m minus 4, not 2. There we go. Okay. Apologize for that. So this is m minus 4. This factors into m plus 2 and m minus 2. Let's write that here. I have to write the entire thing out again. Okay. So now, once again, let's think about our restricted values. Restricted values, once again, are the values that will make our denominator 0. Let's take a look. This time we have 3 separate factors in our denominators, an m plus 2, m minus 2, and m. Okay, so m, for example, if m was 0, then that would make our denominator 0. So m can't be 0. And this one, if m is negative 2, it would make this denominator here and here 0. So m can't be negative 2. And then, as you probably guess, in this case, m can't be positive 2. So we have 3 restricted values. So once again, what we're going to do is we'll come back at the very end, check, make sure that's our solution or solutions is not one of those. If it is, that number won't be a solution. Okay. Now, our LCD works the same way. So now that everything is factored, we have to have all our distinct numbers, all our distinct factors have to be present. Okay. So the distinct factors we have are m, m plus 2, and m minus 2. So actually all 3 have to be there. So LCD is actually m times m plus 2 times m minus 2. So like I said, this takes a bit longer to write. So now, same thing, multiply both sides by that. So m times m plus 2 times m minus 2 times the left side, 3 over m plus 2 over m is equal to the LCD m times m plus 2 times m minus 2 times the left side, which is 4m minus 4. And I'm going to write this denominator in the factored form. Okay, it's easier to work with there. See what cancels out. It's m plus 2 and m minus 2. Okay, just repeat what we did. So we found the same ways we did before, found our LCD. And once everything's in its factored form, it has to have at least all our different factors there. Our different factors are, the different numbers are m, m plus 2, and m minus 2. It has to have all those there. But take that and multiply it by everything. Now, once again, our goal is to get something with no denominators. As we'll see, that will happen. Okay. So let's take a look. Actually, let's take a look at the right-hand side first. What's going to cancel out here is going to be the m plus 2s and the m minus 2s. So what we're left with then is m times 4m minus 4. Okay, on the right. Over here, once again, I have to do kind of a fair amount of writing. So multiply this, since you distribute this to each one. Distribute this whole thing. So m times m plus 2 times m minus 2 times the first fraction, 3 over m plus 2, then plus, then the same thing, m times m plus 2 times m minus 2 times 2 over m. Almost ran out of space. But once again, after this, there'll be no more denominators left. Let's take a look what cancels out, the m plus 2s. So what we're left with then is we have a 3 times m minus 2. Okay, here we have a plus. The m's cancel out. What we're left with then is 2 times m plus 2 times m minus 2. Okay, here I'm going to go ahead on this side, go ahead and distribute the m here. So I have 4m squared minus 4m. Okay. Let's take everything a step at a time, because there's, and like I say, good thing is no more denominators. Okay, that was our goal. Now, take everything a step at a time. So let's go ahead and distribute this. So we have 3m squared minus 6m. Okay, here. Now here we're going to have 2. And here, if you think of the distributor FOIL this out, what you'll have, let's look back. And when we key to this is look back here. We just said if we factored m squared minus 4, you get m plus 2 times m minus 2. So essentially, if you FOIL this out or distribute, you will get that. So I'm just write this as m squared minus 4. Okay. And this side's still the same for now. 4 times m squared minus 4m. Okay. Let's distribute this, combine our like terms. So we still have 3m squared minus 6m, then plus 2m squared minus 8 is equal to 4m squared minus 4m. Okay. Now, once again, as a general rule, combine like terms on this side. So if we combine, we have 3m squared and 2m squared. So we have 5m squared minus 6m minus 8 is equal to 4m squared minus 4m. m. Okay, we're getting closer. All right, so this one does take a little while to write out. All right, what we're going to do now is this is a quadratic equation. And so the way to approach a quadratic equation, the best way is need to get one side equal to 0. So we're going to say we're going to make the right side 0. Okay, so I'm going to subtract everything, move it over here. And so this is going to give me then, so I'm going to subtract 4m squared from everything, from both sides. That's going to give me an m squared over here. I also subtract, at the same time, I'm going to add 4m to both sides. That's going to make this minus 2m minus 8 is equal to 0. So once again, what I did, subtracted 4m squared from both sides and make this just m squared. Then I added 4m to both sides, get rid of this. So this side is now 0. This is going to be negative 6m plus 4m is minus 2m. Okay. Now, you can solve this quadratic equation either by factoring or by using the quadratic formula. It's easier to do by factoring. So I'll go ahead and show you what that looks like. But if you solve the quadratic formula, you get the same thing. So if we factor this, okay, this is then going to be m minus 4 and m plus 2. Okay, now, once it's in factored form like this, you set each one equal to 0. So m minus 4 is equal to 0. M plus 2 is equal to 0. And so our solutions are m equals 4 and m equals negative 2. Okay, now if you do the quadratic formula, get both these as well, 4 and negative 2. Now, once again, take a look at our restricted values. What were our restricted values? We had 3 of them, 0, negative 2, and 2. Those are the values. We plug those in, will make our denominator 0. So we have 2 possible solutions. You notice this one here is not restricted. Okay, but this one is restricted. Okay, so this one is not a solution because to the original equation, if you plug it back in, you make it your denominator 0. It's negative 2. Then you'll make this part here, for example, 0, and actually over here, 0. Now, make sure something's clear. It is a solution. This is definitely m minus equals negative 2 is definitely a solution to this quadratic equation. It's not a solution to the original one. Okay. So then our solution then is actually these two. There's only one. Actually, is m equals 4. So 2 possible solutions in this case. Our solution then is m equals 4. Okay, so that's a good example of what can happen when you have a restricted value, which is a solution. So then it's not a valid solution. Okay, let me see. Make sure I have enough room, more than enough for the last one. Let's do one more example. So this is going to be number, I guess, number 4. Check. Yes, number 4. And we'll start right here. All right, this time we have 3y plus 5 over y squared plus 5y plus y plus 4 over y plus 5 is equal to y plus 1 over y. So once again, we want to factor our denominators, to abbreviate that. Okay, the only one that actually factors is this one. This one's going to become y times y plus 5 if we factor out a y. Okay, now let's go find our restricted values. Okay, so what will make our denominator 0? Clearly, if y is 0, we'll make everything 0, so y can't be 0. And over here, from this one, here and here, then if y is negative 5, it'll make the denominator 0. So we have 2 this time. Y can't be 0, y can't be negative 5. So as we did before, we'll come back at the end and check, make sure the solution we get is not one of those. Okay, now our least common denominator. So we have two distinct factors in our denominators. We have y and y plus 5, because those are repeated right here. And so our LCD has to have both of those. It's going to be y times y plus 5. And like we did in the past, multiply both sides by that. So once again, if you look over here, this is what I say, this kind of procedure, okay? Multiply both sides by that. So we're going to multiply, and this is, once again, this is where a lot of the writing comes in. So y times y plus 5 times the left side, which is 3y plus 5. And I'm going to write this in the factored form down here. Y times y plus 5 plus y plus 4 over y plus 5. Okay. And then your LCD times the right side. Y times y plus 5 times y plus 1 over y. Okay. So our goal right now is to get rid of our denominators. Let's take a look over here. What will cancel out are the y's. Okay. So this side, we're going to have y plus 5 times y plus 1, which we'll have to multiply here in a moment. Okay, and over here, we're going to take this whole thing and distribute it to each part. Okay, so we have y times y plus 5 times this first fraction, 3y plus 5 over y times y plus 5, then plus y times y plus 5, or LCD again, times the second fraction, which is y plus 4 over y plus 5. Okay, so on these, I know there's a lot to do. Just take your, but it's a lot more to, there's more to do, but everything works exactly the same way. Just take your time. Okay, let's see. So here, what cancels out? Here, the y plus 5s cancel out, and also the y's, which is good. So this one, we just have 3y plus 5 left. Over here, the y plus 5s cancel out, and so we have plus y times y plus 4. Okay, so now I need to simplify each side of the equation separately before I actually try and solve it. So over here, either FOIL or distribute. I'm going to FOIL this. Okay, so y, the first term is y times y is y squared. The outer ones, y times positive 1, which is plus y. The inner ones, plus 5 times y is plus 5y. And finally, the last one's plus 5 times plus 1 is plus 5. On this side, distribute the y here. So 3y plus 5 plus, and then we have y times y, which is y squared, then plus y times positive 4, which is plus 4y, is equal to, then we combine like terms over here. These are like terms, so plus y and 5y, it becomes plus 6y plus 5. Okay. And a few more things combined. We combine a few more like terms on the left side, 3y and 4y. And so we're going to have y squared plus 7y plus 5. And then over here, y squared plus 6y plus 5. Okay. Now, notice something. Now, notice you started thinking maybe this is a quadratic equation, and it looks like it. It turns out it actually won't be. So if we subtract y squared from both sides, if you want to get one side equal to 0, subtract y squared from both sides. This cancels out, but actually so does this. And also, if we subtract 5 from both sides, then actually the 5s cancel out as well. Over here and over here. So what we're left with then is 7y equals 6y. Okay, which is kind of strange, but let's kind of approach it the same way. Get the y's on the same side. Subtract 6y from both sides. What we're left with then is y is equal to 0. Okay, so they kind of worked out nice in the sense it looked like a quadratic equation, turned out not to be. Now, once again, is this a restricted value? Let's take a check. Let's take a look. Go back up here, and yeah, it is. So 1 is equal to y equals 0 is one of our restricted values, because if you plug in 0, it's going to make this denominator 0 and this one. So what do we do about that? Well, what this means then, that's the only value we got. So this is a restricted value. Okay, since that's our only solution, so in this case, there is no solution. In this case, we have an equation with no solution. So in other words, there's no value of y I can plug in that will solve this, give us a true statement. without making the denominator 0. Now, it is a solution. This number y equals 0 is a solution to this equation after we, multiply both sides by that, but it's not to the original one. And that's what's important. Okay. Now step back and see what we learned today. So what we saw is that they're called rational or fractional equations when you have a variable in the denominator. So we solve it basically the same way we do any kind of equation with a denominator. So find your least common denominator, multiply both sides by that. Now this had the additional concern we have to find our restricted values or any numbers that make our denominator 0. And so we solve our equation and we have to check if the solution we get is one of our restricted values, that number is not a solution. We saw that a couple times. So this is how we solve rational equations. Thank you. Have a good day.